Okay, with this video, what we're going to do is we're going to look at the Chapter 6 review solutions. I'll go through each one and give you guys the answers, and then the next video will have Chapter 7, the next one will have Chapter 8. Let's start with the first one. Real simple, plug that in your calculator. The square root of 1.69 is A, that's 1.3. For number 2, the square root of a negative number, if you try to put that in the calculator, you cannot find the square root of a negative number. That answer is D. There is no real solution. Okay. Number 3, we have the cubed root of 27, x to the 15th, y to the 24th. Okay, so we've got the cubed root of 27, x 15, y 24. Okay. 27, the cubed root of 27 is 3. The cubed root of x to the 15th, to simplify your variables, you do 15 divided by 3. That's 5. The cubed root of y to the 24th, again 24 divided by 3, that's 8. If they're not divisible by 3, like a couple down in the next problems, I'll show you how to work that out. So that's C for number 3. Okay, not A. We don't have to worry about absolute value with that. Square root of 6 times square root of 2 is the square root of 12. And the square root of 12 can be broken down. So your answer is not B. Square root of 12 is 4 times 3. Or we can make that the square root of 4 times the square root of 3. And we know that square root of 4 is 2. So that's 2 square root of 3. So that's A. So if you have B, you just didn't simplify it enough. 5, we can just multiply those two numbers. It's the 4th root of 33. And we can't do anything else with that. That's D. For number 6 we're going to have to start looking at a little bit bigger screen here. And this is where it gets a little bit more complicated. So I'm going to bring 6 out to the next page. Of course, it doesn't always work as easily as we want to. Let's just make it a little bit bigger. There we go. The cubed root of 128, a to the 13th, b to the 6th. Okay? Well, if we want to work with that one, the cubed root of 128, we don't know what that is as a perfect cube, but I can break this up into 2 cubes. I can break this up into the cubed root of 64 and the cubed root of 2, because 64 times 2 is 128. Now, why I use 64 is 64 is an actual perfect cube. A to the 13. Again, 13 is not divisible by 3, so I need the next smallest number below 13 that's divisible by 3. That'd be 12. So that's a to the 12th. Well, if I have a to the 12th, I have to have one more to add up to 13. And then 6 is divisible by 3, so we're just going to leave that put. Okay, the cubed root of 64 is 4, so that's 4. The cubed root of a to the 12th is a to the 4th. Now I skipped 2 because I don't know that, so that's going to have to stay under the cubed root. And then the cubed root of b to the 6th, that's b to the 2nd. And then we're left with the cubed root of 2a. So for number 6, it's 4a to the 4th, b to the 2nd, times the cubed root of 2a. That is a. Okay. Now, if you did number 6 and you're like, okay, now I want to try number 7, go ahead and try number 7 and see if you can figure that one out. So we're going to work out number 7 as well. So number 7 we'll make a little bit bigger. We'll come out over number 6. We'll make this huge number 7 here. Okay. So let's break this up. Cubed root of 108. Cubed root of 108. 108 is 27 times 4. And 27 is a perfect cube, 4 is not. 16, again, that's not divisible by 3. So we need to make that the next smallest number below 16 that's divisible by 3. And 9 is divisible by 3, so we're good there. I don't know why I put another branch to that. Okay? So when we simplify this, cubed root of 27, that's 3. So we've got 3. I'll write that down here. We don't know what the cubed root of 4 is, so that'll stay under the cubed root. We've got a to the 5th, b to the 3rd, and we're left with the cubed root of 4a, because that's what stays under. So that appears to be, b to the 3rd, that's a. So 7 and 8 were both A, or 6 and 7. Okay, let's go on to the next page, or the next couple questions on this page, and then we'll go to the next page. All right, zoom in a little bit. That might make things a little bit easier for us. There we go. Okay, number 8. Again, multiply straight across. Okay, so when we do this, we've got the cubed root of 7 times 9, which is 63. And then x to the 7th times x to the 4th is x to the 11th. Now when you look at these two, 63 doesn't have a perfect cube that can go into it. So 63 is going to remain underneath the cube. So really all I have to break up is this x11. So the next smallest perfect cube is x9, and I would have x squared left over. So the cubed root of x to the 9th is x to the 3rd. That's what would come out front, because 9 divided by 3 is 3. And then what's remaining underneath is the cubed root of 63 x squared. So that one is also A. All right, let's move to the next page. Going a little fast there. Okay. Number 9, the quotient we divide. This is the same as the cubed root of 81, and 81 is the same as 27 times 3. Now why did I pick 27? Because it's the largest perfect cube that goes into 81. The cubed root of 27 is 3, so this is 3 times the cubed root of 3. Now we have two answers here. If this were to happen on your final exam, we would just pick the first one. So in this case, we're going to pick A. Okay? All right, let's look at number 10. And we'll ignore C. 270 x to the 20th over 5x. We need to divide first, so we have just one cube. So 270 divided by 5 is 54, and x to the 20th divided by x is x to the 19th. Remember, we subtract those exponents. So 54, again, can break into the cubed root of 27 and the cubed root of 2. X to the 19th, okay, 19 is the same as 18 and 1. So it's x to the 18th times x, or the cubed root of x. Okay? So the cubed root of 27, is 3. So that takes care of that one. The cubed root of x to the 18th is x to the 6th. That's what can come out. And the rest of it has to stay underneath, so we're left with the cubed root of 2x. So 3x to the 6th cubed root of 2x, I believe that is B. All right, number 11, adding, they have a like term. The cubed root of 2x is just like saying x. So this is just like looking at 2x plus 6x. It's 2 fourth root of 2x plus 6 fourth root of 2x. But that's the same thing. So the answer is 8 fourth root of 2x, or C. Do not try to add the interiors. That does not work. Number 12, a garden has a length and width. What's the perimeter? Well, perimeter is 2 times length plus 2 times the width. So 2 times the length, so 2 times radical 13, plus 2 times the width, 2 times 7 radical 13. 2 times 7 is 14, so this is 2 radical 13 plus 14 radical 13, which is 16 radical 13. And that appears to be B. For number 13, we have to make sure that these are each in simplest radical form. So the square root of 20, well, that's 4 times 5. So this is 2 radical 5. The square root of 45, that's 9 times 5. Square root of 9 is 3, so that's 3 radical 5. So I'm going to do 2 radical 5 plus 3 radical 5 minus radical 5. So 2 plus 3 is 5, minus 1 is 4, so that's A. Okay. This one we have to FOIL first. 7 times 8 is 56. Outside, 7 times radical 2 is 7 radical 2. Inside, negative radical 2 times 8 is negative 8 radical 2. And last, negative radical 2 times radical 2 is negative 2. So when I combine my like terms here, 56 minus 2 is 54, and 7 radical 2 minus 8 radical 2 is a negative 1 radical 2. So that answer is B. Moving on to number 15 and 16. 15 you may or may not recognize that's the difference between two squares. If you don't, that's fine. Just FOIL it. If you FOIL it, it's 5 times 5 is 25. 5 times positive radical 2 is 5 radical 2. Inside negative radical 2 times 5 is negative 5 radical 2. You can see these are going to cancel out. And then last, negative radical 2 times radical 2 is negative 2. 25 minus 2 is 23. That answer is A. Okay. That's the same as doing A squared minus B squared. So I could have done 5 squared minus radical 2 squared. That would have given me the same answer. Okay. Number 16, the first thing I'm going to do is add 7 to both sides of this equation. And I get radical x plus 10 is equal to 2. Then you square both sides. And we get x plus 10 is equal to 4. Subtract 10 from both sides. And we get x is negative 6. So that is D. All right, looks like we have 2 more for this chapter. So again, move the 10 to the right. And I would move that by adding 10 to both sides. So I have radical x plus 8 equals 6, right? Because negative 4 plus 10 is 6. Square both sides. So x plus 8 is 36. Then subtract 8. So x equals 28. So it's B. Okay. Number 18. Number 18 requires a little bit more work. First, move the 3. So I get, I'll bring it up here, I get 2 times the 5th root of x plus 6 to the 3rd power is equal to 16. Then we divide by 2. And I get the 5th root of x plus 6 to the 3rd power is 8. To get rid of the 5th root, you have to raise both sides to the 5th power. Okay? So I'm going to get x plus 6 to the 3rd power equals 8 to the 5th power. And 8 to the 5th power is a pretty big number. Let's check what that is. 8 to the 5th power. Let's clear this out. 8 raised to the 5th power is 32768. And then to get rid of this, I have to take the cubed root of both sides. So if I want to get rid of a cube, I take the cubed root. If I want to get rid of a 4th power, I take the 4th root. So I'm going to get x plus 6 equals whatever the cubed root of that is. So I'm going to come back, and this is where I love these calculators, because I can do the cubed root by hitting math, and it's number 4. There's the cubed root. And then instead of retyping that in, I can just hit second and the minus sign, and it puts the answer from the previous one in. So that's 32. Minus 6, I get x equals 26. So that's A. All right, so that's chapter 6. Again, I went kind of quick through that, but you can stop and you can pause and you can go back and you can rewatch if you need to.